Once you have your block milled square, you want to start milling it down to the dimensions on a blueprint. So for today's demonstration, let's just say that I want to make this block 1 inch by 1 inch. So I've already got the outside milled all the way around, and I know that sides 2 and 3 are parallel, so therefore this is a square block. So if I want to mill it down to 1 inch, once again we got to get some parallels out. If the vise measures about 1.75 inches deep, and I know I need a 1 inch block sticking out of it when I'm done, I have to have parallels of at least 3/4 inch. So I selected the parallels of 15/16. In order to hit those sizes, I'm going to be using my micrometers to measure my part and keep track of where I'm at. As I measure my part, I have to determine how much to take off after taking a pass, and that's where the Z handle comes in handy. That dial around the outside reads thousandths of an inch. So if I take a reading of this, and let's say I have 200 thousandths stock, I would have to turn this handle 200 thousandths. So let's first, before we start, let's measure our piece and see how big it is. So right now it measures 1 inch, 203 thousandths. So I know I have about 200 thousandths to take off of here. On a machine like this, with this kind of cutter, I want to say your maximum depth of cut should be about 50 thousandths. So knowing that, that would be 4 cuts to get it down to size. But as you noticed when I milled it the first time, when I squared it up, I took a rough pass and then I took a finish pass. So I also have to remember to take finish passes. A finish pass makes your part more flat and gives you a better finish. If you take your last pass as a rough pass, your part will be not as precise. So I want to save 5 or maybe 10 thousandths for a finish cut. So I got to keep this all in mind when I'm machining this down so I don't go too far. There are formulas for calculating feed rate as well. You have to look on your chart here too. We have the carbide face mill. That's what we're using. Then there's 2 types of face mills. There's either a 0-degree lead or 45-degree lead. This one is a 45-degree lead. That's what they mean by that. They're looking at the cutter. There's a 45-degree angle on the lead of the cutter. We're cutting mild steel, so it's telling us to feed at 8 thousandths of an inch per tooth. On this cutter, there are 4 teeth. So here, when you're calculating feed rate for milling, you're looking at inches per minute. Your inches per minute is your chip load per tooth times your number of teeth times your RPM. So your load per tooth was 8, your number of teeth is 4, and you have to times your RPM. So this is where you're probably going to need your calculator. If you take the 800 RPM we've already figured out, times that 8 thousandths feed per tooth times 4 teeth, it tells you you're going to feed at 25.6 inches per minute. So what does that mean? Inches per minute's kind of like miles per hour. When you get in your car and drive, you're going a certain distance in a certain time. Miles per hour is different than inches per minute though. I'm looking for how many inches that we're going to go in 1 minute. So if you wanted to stand here with a stopwatch and you'd start it, you would feed this for 1 minute, you would travel 25 inches. So since we're only going about 5 inches, it should take us 1/5 of a minute. So you kind of use that to estimate. You should be able to do that in 1/5 of a minute. So figure, I don't know, 20 seconds maybe, something to get all the way across. Because you got to go the 5 inches of the material plus the 2-inch cutter on both ends. So it's maybe more like you're feeding 8 inches, I guess. So just kind of use that to get you close. If you were programming this machine, that would be the number you'd program. But we're just going to hand feed on this project. I don't want you to feed too hard. Just feed nice and even and nice and steady. I'm going to be high gear. We've already figured out the speed for this cutter was 800. And we figured out the feed rate was about 25 inches a minute. So I'm at 800 yet. I'm going to bring the workpiece up just until it touches the cutter. Now I know from measuring that I have about 200 thousandths of stock. Now I know when I touch it, I've removed a little bit of it. I would say I remove less than 5 thousandths. So what I'm going to do now is I'm just going to zero it first. Like I said, we could probably take a 50 thousandths cut. That's 0.05 inches. On this dial though, it reads thousandths of an inch, so I have to go to 50 on this dial. Make sure you clamp your Z-axis. Your Y should be clamped, we're not moving Y. X should be unclamped. Now when I start cutting, you're gonna hear the machine cutting pretty good. This is a pretty good size cut for this machine. Now with this rough pass, there's a lot of vibration and a lot of impact with the cutters on the material. So that is why a rough cut's not precise. If you were to take a look at this, you can see where it's really rough. It doesn't even look precise. You can see by just how it looks that it was a rough cut. So let's take a 5/1000 finish cut. We'll look at the difference in the two finishes. So with the lighter cut, I actually get a better finish and a more precise part. So let's move the table away from the cutter so we can measure this. I want to see what size we are now. This side measures 1 inch, 41 thousandths. I'm going to check the other side right away. The other side measures 1 inch, 41 thousandths as well. It's very important to check both sides. You want to make sure that your part is in the vise straight. If you only measure one end, the other end could be higher or lower just because of something in your setup that made your part not parallel. So you want to make sure that your part is in the machine straight. So always measure both ends. So right now it says that I have to go, I'm going down to a 1 inch size. If it measures 1 inch, 141 thousandths, I got 141 to go. So now that I've actually taken this pass with a finished cut and I have not moved the dial, I should be able to re-zero this dial right now. And just to practice hitting size, I'm going to try to hit 1 inch 100 first. I have 41 thousandths to go then. So I'm going to crank the table up. Let's go 36 thousandths. That way there, that'll save me exactly 5 for a finished cut. And we'll take that 5 thousandths finished cut right away. So I'm going to take it to 41 thousandths on the dial. Okay, now I'm going to measure my part. It should be exactly 1 inch 100 thousandths. And it measures 1 inch 100 thousandths. So I now know that my dial is set properly. So I have another 100 to go. So 41 plus 50 is 91. This will be a 50 thousandths rough pass. So I should have 50 thousandths to go yet. So I'm only going to take 45. It might be easier to re-zero it at this point instead of counting from 91. So now at 0, I'm going to take 45. And that should leave me 5 thousandths for a finished cut. Take off your last 5 thousandths and your part should be exactly 1 inch thick. My part is exactly 1 inch thick. So at this point now you can remove your part and deburr it. So that's face milling a block to size. If you had to go 1 inch by 1 inch, you would have to repeat the same process now on this side.